position. So here you can see we have given an array and a target element. We have to return its position. So you can see target is 5. It's reside in 0 1 second position. So we have written that. In the same way, target is 2 in another example. Here you can see 2 does not exist and it must be here. So we have written the first index. In the same way, the 7 must be right after the 6, so we have written the position 4. Besides this, you can also see the array is always sorted, and we have to do the solution in log n time complexity. So for this, we mostly go with the approach binary search because its solution give us log n time complexity. So for this, we have to take a left pointer and right pointer for binary search, and now based on left plus right we can calculate a mid position. So what we have to do for the mid equals to left plus right divided by 2, so this will give us the mid position. So in this case the mid would be here, and based on this mid condition we can increment or decrement the right and left pointer and check if its value is equals to target or not. So for this case, if you can see, mid is right over the fifth index, and if you see in example 1 target is equals to 5 and output would be 2. So you can see mid is pointing to 5, so we can check if no target is equals to nums array mid, then simply return from here with what we have to return. We have to return the m index position. Okay, and now if we take another example where the target needs to be 2 and 1, now let's say extend our example. 2 must be reside over there, here. Okay, so you can see we compare if mid value is greater than target. Here you can see target is 2 and mid is greater than target. So uh, else we can go else if target is less than nums array mid, then for this case what we have to do, we have to change the right position to mid. The change right equals to mid. Okay, now the mid is here. Now as you can see we need some kind of iteration to check at each position, right? So for this what we can do, we can do a while loop and check if left is while left is less than right position, do a while loop, else came out of this loop. So you can see the mid is here, right is here. Now again we have to calculate mid, left plus right divided by 2. Now mid become this. Now again we check if target is equals to nums array I. It's not the case, it's less than. So again we go inside this loop and change our right index here. Now same, left is less than right, so our iteration continues and mid would become this. Now in this case we check the target is 2 and our current number is 1, so means we have to uh, change the left pointer because the value it's not the case. Then what we had, the case is like this, our target is now greater than nums array I. So for this what we have to do, we have to increment the left pointer. So for this case we have to plus 1, we have to increment the left pointer with mid plus 1, and now as you can see we again came out of this loop and check left is while left is less than right. It's not the case, so we came out of this while loop, and in the end we can simply return the left pointer. So for this, what it would return the 1. So this is the case. Hopefully you get it. Now let's try to code it as well. Let left equals to 0, and we can start right with nums dot length, and then we can do a while loop while left less than right, then go inside and check. Let's take a mid value as well. Left plus right divided by 2 will give us the mid position, and we have to do a math dot floor as well, because if the array element is 5, so 0 plus 5 divided by 2 will give us 2.5. We have to do a floor as well for this case, for the odd position. Okay, and then what we were doing, we were checking if target is equals to sum nums array mid, means we get the index and simply return it, else we can check if target is less than target, let's suppose is less than nums array mid, then we have to do a right equals to mid, else simply do a left equals to mid plus 1. Okay, mid plus 1. Okay, do a m here as well, and in the end we can simply return left. Now let's try to run it. Hopefully this works.